Welcome back, students. I hope you are all safe at home. Today we will continue chapter 1, laws of motion. We'll do the second part. Here we are going to study Newton's laws of motion. We have already studied kinematic equation. Here we will study some laws of Newton's laws and certain equations. Okay, the topic which we are going to cover here, Newton's law of motion and related equations. Okay, what is Newton's law of motion? Newton has given three laws of motion. The most important concept is gravitational motion, which he has given because of the apple falling down. You all know that theory. Now, there are three laws of motion which Newton has devised. For that, let us understand some points here. A static object does not move without the application of a force. What is the meaning of static object? An object which is kept stationary on the table. A book will not move on its own. What do you have to do? You have to either lift the book, push the book. Yes, so you have to apply some force. The force which is sufficient to lift a book from a table is not sufficient to lift the table. Correct. You can lift the book, but can you lift the table at the same time? No. Fruits on a tree fall down when its branches are shaken. Tree doesn't fall down, only the fruits fall down. An electric fan keeps on rotating for some time even after it is switched off. Science is there in your home also. Every day you observe these things, but you have never tried to understand the logic or scientific reason behind this. Let us study the most important science behind, or most important concepts of science behind this. We have realized that the objects have some inertia. We have learned that inertia is related to the mass of the object. Newton's first law of motion is related to inertia. He has given you a simple example. Take a glass filled with sand, keep a piece of cardboard over it and a 5 rupee coin. Strike the cardboard hard using your fingers. What will happen? Simple. The coin will fall down into the sand. Right? Okay, you have played tug of war. So long as the force is applied by both the sides, nobody falls down. It is balanced. Okay, you are nicely standing in your place or sitting in your chair. Nothing happens. You don't fall down on your own, right? So this is called as a balanced force. Unless and until your friend comes and pushes you very hard from behind, you fall down. Right? Now, when your friend comes and pushes you, this is unbalanced force. Now, to make you fall, he has to apply force more or much larger than the force with which you are standing. That is your body weight. So, this becomes an unbalanced force. As long as the force applied by both the sides are equal, it is balanced. Center of the rope is static in spite of the applied force. On the other hand, when applied force becomes unequal, a net force gets applied in the direction of the greater force and the center of the rope shifts. You all know how you play tug of war. What is Newton's first law, or that is the law of inertia? An object will continue to remain in a state of rest or in a state of motion. See, for example, you are sitting, you will continue to remain sitting unless and until your mommy tells you, get up and get something for her. Then only you'll get up. Or somebody comes and pushes you out of your chair. So you will continue to remain in a state of rest. Or in a state of uniform motion. The car will continue to move on the road unless and until you apply brake. So an object will continue to remain in a state of rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. When an object is at rest or in uniform motion along a straight line, it does not mean that there is no force acting on it. You are having gravitational force acting on you. But the number of force acting on it, but they cancel one another, so the net force is 0. Newton's first law explains the phenomena of inertia, the ability of an object to change its state of motion on its own. Okay? Let us go to Newton's second law. Newton's second law is related to momentum. That means for moving objects. Take for example, your friend has dropped one plastic ball and one rubber ball from the same height. You catch the balls. Which ball are easier to catch and why? Plastic ball or rubber ball? Think about it and give the answer. Okay, you all play cricket and I gave you an example of the cricket in the first session also, where it is easier to catch the ball close to the ground, right? Momentum has magnitude as well as direction. What is momentum? The effect of an object striking another object depends both on the mass of the former object and its velocity. This means that the effect of force depends on the property related to both mass and velocity. This property is termed as momentum. If an unbalanced force is applied on an object, it causes a change in the velocity of the object, then it is also causing a change in its momentum. The force necessary to cause a change in the momentum of the object depends on the rate of change of momentum. You all play marble, right? You have to hit a marble or carom. You are playing carom. What do? You use a striker to hit the coins, right? Now when you are hitting the striker, the coins get displaced. Yes or no? So to displace the coins, you have to take into consideration the mass as well as the velocity with which you want. You have to put it into the respective corners. So you should know what velocity should be applied, how much force will be required to cause that change. Your momentum will depend on magnitude as well as direction, which pocket of the carom board you want the coin to go. Yes or no? You are playing cricket. You have to throw the ball. You have to hit a 6. So you should know what speed the bowler is going to bowl. So you should know the mass of the ball as well as the velocity of the ball. And if you want the ball to go for a 6, you should know how you have to overcome that momentum and strike it. So यहाँ पे Newton's second law of motion is related to momentum. It is represented by the letter P. It is a product of mass and velocity of an object. The rate of change of momentum is proportional to the applied force and the change of momentum occurs in the direction of the force. What direction you will apply the force? The object will move in that direction. You are kicking a ball on the football ground into the net. It will go into the net for a goal, right? So your force is applied where? Your force is applied in the forward direction. The ball will also go in the forward direction. We have one small equation here. Suppose an object of mass m has an initial velocity u. When a force F is applied in the direction of its velocity for a time t, its velocity becomes v. Initial momentum is represented as mu. Final momentum after time t is mv. Rate of change of momentum is change in momentum upon time, which is represented as mv minus mu upon t. Now mass of the object is common here, so we'll remove it. V minus u is put in bracket upon t. Now V minus u upon t is nothing but acceleration, which I have studied in Newton's first law. Kinematic equation. So according to Newton's second law of motion, rate of change of momentum is proportional to the applied force. So mass into acceleration is proportional to force. So force is equal to mass into acceleration. K here is a constant of proportionality. Consider two objects having different masses which are initially at rest. The initial momentum for both is 0. Suppose a force F acts for a time t on both the objects. The lighter object will start moving faster than the heavier object. However, from the above formula we know that rate of change of momentum F is both the object is same and total change in their momentum will also be same. Remember I put a question. plastic ball and a rubber ball. Which one will come down faster? Both of them will come down at the same time. Okay. Unit of force in SI system is Newton. 1 Newton is 1 kg into 1 meter per second square. Now, why is there a thick bed of sand for a high jumper to fall after his jump? You all have sports day, so you have got high jump. And when you fall down, high jump or a long jump, you have a thick bed of sand. Why do you think that is required? We'll study this with respect to Newton's third law of motion. Now, in Newton's third law of motion, every action there is an equal and opposite reaction, and this reaction is instantaneous. Now, how this reaction is instantaneous? The example given here, I'll give you better examples. You kick the door of your house, right? You come and kick the door of your house with lot of force. What happens to your leg? You get a pain in your leg. Why you get a pain in your leg? You have kicked the door. The door should cry. The door should be in pain. But nothing happens to the door. You feel the pain because when you have applied a force on the door has also applied an equal and opposite force immediately on you. That is why you have pulled your leg backward. So for every action, equal and opposite reaction. You are playing football, right? So you are kicking the ball. Now, after you kick the ball from the ground, does your leg remain in the air only? No. It comes back. Why does it come back? Because whatever force you have applied to the ball is also applied in equal force in the opposite direction. That is why your leg has come down. In nature, force cannot occur alone. Force is a reciprocal action between two objects. One object action, another object reaction. So when an object applies a force on another object, the latter object also simultaneously applies a force on the former object. The force between two objects are always equal and opposite. This is Newton's third law of motion. Action and reaction are terms that express force. They always act in pairs. One force cannot exist by itself. Action and reaction forces act simultaneously. Action and reaction force always acts on different objects. Your hand is doing the action, the ball is giving the reaction. They do not act on the same object and hence cannot cancel each other. I have given you some examples here. While hitting a bat with a ball, the speed of the bat changes. A gun recoils, it moves backward when bullet is fired, or firing of a rocket. Now, when you fire a rocket, fuel is ignited. The fuel throws out smoke. The smoke comes out from a small hole onto the ground. So the ground also exerts an equal and opposite force and the rocket is pushed upward. So this is your Newton's third law of motion. Now we have talked about action and reaction force, and I gave you an example of playing carom board or marble, right? See, law of conservation of momentum. For every action there is equal and opposite reaction. So there is no loss, no gain here. If one object is losing, the another object is gaining that much amount of force. Suppose an object A has mass m1 and its initial velocity is u1. Another object B has mass m2 and its initial velocity is u2. According to the formula of momentum, initial momentum is m1 u1 and for B it is m2 u2. If these two objects collide means hit one another. That is what I am talking about, playing a carom board or marble. The force on A due to B is F1. So your striker is A Your queen on the carom board is B. So you have hit the striker to the queen. So that force is F1. This force will cause acceleration in A and its velocity will become V1. Momentum of A after collision, after you hit the striker, will be M1 V1. According to Newton's third law, A also exerts an equal force on B but in the opposite direction. You have applied a force on B. That means striker has applied a force on the queen. The queen will also apply a force on the striker. This will cause a change in the momentum. Now the momentum of B after collision will be M2 V2 and force will be F2 but in the opposite direction. Okay. So if A is the striker, B is the queen, or if A is the queen and B is the striker, let us take it this way. Then the momentum of B after collision will be M2 V2, but if force applied acts on object, but it will be given as F2 is equal to minus F1. Why minus? Opposite direction. That is why your minus sign is indicated. So force is given as mass into accelerations, but we are representing two different objects here. So M2A2 is equal to minus M1A1. F is equal to M into A. Now M2 we take it outside. What is A acceleration? V2 minus U2 upon T. Here it will be V1 minus U1 upon T. T is common on both the sides, so you can cancel it out. What remains is M2 V2 minus U2 minus M1 V1 minus U1. Open the bracket. M2 V2 minus M2 U2 minus M1 V1. Minus into minus is plus M1 U1. Take M1 V1 this side. So M2 V2 plus M1 V1 is equal to M1 U1 plus M2. U terms on one side and V terms on one side. What are you going to get? Total momentum. Final momentum is equal to total initial momentum. If no external force is acting on two objects, then the total initial momentum is equal to total final momentum. This is true for any object on the earth. When no external force acts on two interacting objects, the total momentum remains the same. That is what I am telling you. One object gives and the other takes. The total momentum remains the same. There is no loss, no gain. When two objects collide, the total momentum before collision is equal to the total momentum after collision. They have given you the concept for firing a bullet from a gun. When a bullet of mass M1 is fired from a gun of mass M2, its velocity becomes V1. Its momentum will be M1 V1. Before firing the bullet, both the gun and the bullet are at rest, hence their initial momentum is 0. According to the above law, the final momentum M1 V1 plus M2 V2 is equal to 0. Right? So, the backward motion of the gun is called as a recoil. As the mass of the gun is much higher than the mass of the bullet, the velocity of the gun is much smaller than the velocity of the bullet. The magnitude of momentum of bullet and that of the gun are equal and the directions are opposite. Thus, the total momentum is constant. Total momentum is also constant during the launch of the rocket. So, we have completed the first chapter in Science 1, Laws of Motion. Any difficulty? You can please ask the questions when required in the next session. I hope you have understood the concept. Thank you very much.